if you were looking at this one, you could just say 4 times what equals 8, right? Which is what?
2.
So then multiply your 6 by 2, and you will get your answer of 12. If you did cross multiply, I actually would recommend reducing this first. If you can reduce one of your fractions, obviously you cannot reduce the one that has the x, but you can reduce the 4/6. How do you reduce that? 2, so you can make it 2/3. So if you did cross multiply and you can reduce a fraction, reduce your fraction first before you cross multiply. It makes your number smaller. So this one you didn't necessarily have to because it did go in nicely. But if you do cross multiply, you can reduce a fraction. Now remember, you can't reduce crossways because that's an equal, not a multiplication, but you can always reduce up and down. So make your number smaller if possible, less room for error. All right, for this one, you didn't have anything nicely that went into that, so you're going to end up dividing. So you will have to cross multiply here. 3 times 7 equals 4 times x. So we have 21 equals 4x, and then just divide by your 4. And you will want to leave these as fractions. 21/4 does not reduce, so that is your answer. 21/4 is your answer. Now again, I am going to have to cross multiply here, but can I reduce? Yes, 6/8 reduces. So if I can reduce it, I'm going to do that to make my numbers smaller. What goes into both 6 and 8? Yeah, 6 and 8 is a 2. So I can reduce this to 3/4 before I cross multiply. You cannot reduce this second fraction because you have an x plus 6 on the bottom. But I can reduce the first one, and then I can cross multiply here. So I can say 3 times this group, 4 times that. So 3, remember when it is a plus or minus, you do have to do your grouping symbol. 3 times x plus 6 equals 4 times 10. You do have to distribute. 3x plus 18 equals 40. You're going to subtract. So you have 3x equals 22. Again, you're going to want to divide both sides by 3, and since it doesn't reduce, that will be your answer. 22/3. All right. What about number 4? Can I reduce?
Yes.
Yes. 4/8 becomes 1/2, right? And now I can cross multiply. So I'm going to say 2 times this group. 2 times n minus 9 equals 2 times 1. You do have to distribute. 2n minus 18 equals 2. You're going to add your 18 to both sides. So you have 2n equals 20. And then you are going to divide by your 2. And that one works out nicely to just be 10. So you should have gotten 12 for number 1, 21/4 for number 2, 22/3, and then 10. Fibonacci sequence is how they're added to the shell or how they're added to the pineapple. It's in the sequence of those numbers. Those numbers are found absolutely everywhere, including the ocean waves and the galaxies. So it's not even organic maybe materials that all the plants do this or all the animals do this. You can even see it in the curvature of the waves and the spirals of the galaxies. But what you'll see when you see it in plants is you'll see similar figures. Similar figures are figures that look the same but have different sizes. So they will have the same exact shape, they will just be in a different size, which is what you saw in that video when you started seeing those repeated patterns. They were the same shape, sometimes the larger sizes. And so those are called similar figures. And they have an example of a similar figure up here with a triangle. All right, the triangles are shaped exactly alike, but you will notice that this triangle, the red triangle here, is smaller than the blue triangle. These are called similar figures. By definition, they have the same shape, but not necessarily the same size. Similar polygons specifically are polygons that have the same shape and shape, but not the same size. And one thing that happens when you have similar polygons is all of your angles will be exactly the same. So if you were to take something and measure this angle, if you were to take a protractor and measure this, it would be the same exact angle measure as this one. A would be the same angle measure as X, and B would be the same angle measure as Y. What you'll see with the side lengths is they form ratios, and they form the same exact ratio. So if you were to put the length of this XZ over the length of this AC, it would actually equal the fraction if you were to put YZ over BC. Those fractions would be equal. They would be equal ratios. And so you can use that to solve for sides of polygons by doing cross multiplication. All right, so let's look at this first example. And this example is on page 106 in your books. A couple things about similar figures. I want you to notice the notation for similar. So the notation just looks like this curved line here. All right, this little curved line. It looks like the thing above the congruence line, if you've ever seen the congruence where it's an equal sign with this little guy above it. They're not congruent. Congruent means the same. Similar means they look the same, but they're different sizes. So this is just the little notation for similar. And by writing it like this, they actually tell you some information. They tell you that A would be equal to X in its measurement, that B would be equal to Y in its measurement, and that C would be equal to Z in its measurement. So the order matters when you write your similar. It also tells you that AB would be the side length that corresponds to XY, that BC would correspond to YZ, and that AC would correspond to XZ. So they've written it in a specific order so that you kind of know how those things are similar. So if I were to look at this example here, they are telling me that this ABC is similar to XYZ. And so I can assume that the XZ is the one that goes along with the AC, and that the XY goes along with the AB. And so then I can solve my proportions. All right. Now, a couple things about this. They want me to find XY. It's always important that you know which one they're talking about. So this is where, when you get a worksheet, you may want to get a colored pencil or a highlighter and highlight the line that you're looking for. Make sure you know which one you're looking for. All right? We're looking for XY. So what we're going to do is we're going to set up a fraction with the other two. Set up a fraction with the one that you have both of them. I have XZ, and I have AC, and those correspond to each other. So my XZ goes along with my AC, all right? Which means that my XY, which is what I'm looking for, goes along with my AB. Now, I don't know my XY yet, so they have given me a variable. If they don't give you a variable, just assign one to the one you're looking for. In this case, they gave me a variable, all right? All right, so I know AC. I'm going to fill that one in. And I'm going to say that is 5. I don't know XY, so I'm going to leave that as a variable, but I do know what it corresponds to, the 5.7. All right? 5.7. Now, here's a weird question. Can I reduce any of those fractions? Yeah. Do you notice that 2.5 and 5 are related somehow? Yeah, it's exactly half, right? So I could actually reduce that to be 1/2, which is actually what I would do here. Why do you think I'd do that? Because if I cross multiply, I'm going to be multiplying decimals, right? Which I'm still going to have to deal with decimals a little bit, but a little bit less if I recognize that. So I would actually reduce this guy to 1/2. Does everybody see that 2.5 is half of 5, right? So I can write that as 1/2. And this is going to be a little bit easier to cross multiply, don't you think? All right, so now I have this set up. I can cross multiply. I can say, well, 1 times 5.7 equals 2 times m. And then I can divide both sides by 2. So I have 5.7 divided by 2. Now for these, unless I tell you, if I give it to you with whole numbers, you can leave it as a fraction, but if I give it to you as decimals, you want to leave it as decimals. We don't want to leave a fraction and a decimal in my answer. By that I mean, you would never say 5.7 over 2. 5 halves would be fine, but 5.7 over 2, not so much. So we need to actually do out our division here, right? So we do want to divide this out. How many times does 2 go into 5.7? 2 goes into 5 how many times? 2, right? And it goes into 17 how many times? 8. And then we need to drop a 0. Goes into 10 how many times? 5. So I have 2. That means this guy right here is 2.85. All right? So when you have similar figures, you are going to set up fractions and then solve by cross multiplication. Solve by cross multiplication. All right, let's look at the next example. Good, okay, just the perimeters. So they gave us exactly the same problem actually that we solved for, right? So we solved that this was 2.85 to 5.7. We knew this was 2.5 to 5, and then they gave us this one right here, 7.25, all right? Now, here's the thing. We know that they are in 1/2, all right? So we just figured that out. So we have 2.5 and 5. We're missing a side length. So that's going to be, I had my numerator there. This is going to be corresponding to this guy, right? And so we could do the same thing to solve for that n. We can reduce this to 1/2. And we can cross multiply. So we have 1 times 7.25 equals 2 times n, and we would divide. Let me get this crazy decimal here. All right, what you're gonna find is not only do the side lengths do that, the side lengths will always be in a 1/2 ratio. So if I put 2.5 over 5, I'm gonna get 1/2. If I put 2.85 over 5.7, I'm gonna get 1/2. And if I put that crazy decimal we just got over 7.25, I'm gonna also get 1/2. That's what always happens if they're similar. They will always reduce to the same fraction. That's what equivalent fractions do, and that's what ratios do, okay? So if I put every corresponding side length, by corresponding I mean xz corresponds to AC, if I put that in fraction form, xy to AB, if I put that in fraction form, and then yz to BC, if I put that in fraction form and reduce them, they will all reduce to the same fraction. They're equivalent fractions, right? Something else that happens is the perimeters do the same thing. So if I were to add up all my side lengths, that would also be a 1/2. If I put this perimeter over this perimeter, I would get 1/2 as my fraction as well. They will always reduce to the same fraction. So you can set them up as a fraction and make them equal and cross multiply. All right, and we're gonna do a couple more of those. Let's talk about this one. They said that JKL corresponds to XYZ. So I have X and Y. That should correspond to JK. So I have XY here. That should correspond to JK. So if I have XY, that corresponds to JK. I have both of those, right? I have a measurement for both of those. Make sense? So my fraction is going to be 10 over 32. That's my fraction for this particular one. It's called a similarity ratio. Similarity ratio. Can I reduce that similarity ratio? Can I reduce this fraction? By what? What goes into both of those? 2. So that reduces to 5/16. That means every single side should equal that ratio. So then I have to look at what are my other sides. First of all, they want me to solve for A. Which side does YZ correspond to? KL. All right. So I know my KL. My KL is what? How long is KL?
15.
KL is 15. Do I know my YZ? No, that's just A. But that should equal this fraction for the one that I had 2 of. So that should equal 5/16. Can you solve that? Yes, by cross multiplication. That will solve for A. They also want us to solve for XZ. Which side does XZ correspond to? JL. Do I know JL? Yes, that's my numerator. Do I know XZ? No, but that should equal the same fraction where I knew both of them. That should equal 5/16. Can I solve that? Yes, cross multiplication. So go ahead and solve for those 2 sides. Find the height of the flagpole at the Parliament House in Canberra, Australia, if it casts a shadow of 76 feet on the ground. At the same time that Sydney, who is 5'3", we're going to just say Sydney's 5 feet tall, casts a shadow of 1/6, we're going to say he casts a shadow of 2 feet. See what I did there? Change those, okay? So here's the thing. If you are looking at shadows, it is from the same angle of the sun, right? Assuming they're close enough. So they create these similar triangles. And so this is one way that they calculate kind of the height of something that is really tall. They can use ratios, all right? And so we do not know the height of this particular flagpole right here. But we do know the length of the shadow. The length of the shadow is 76, okay? We also know the height of the person looking at it. Person is 5 feet tall and their shadow is 2 feet long. And so we have this similar figure. So we can assume then that the shadows correspond to each other, right? And we can also assume that the heights correspond to each other. And so we can figure out the length here. We can say, well, if 2 corresponds to 76, then 5 should correspond to the height of the flagpole. Now, once again, I can reduce, can't I? 2 and 76 are both divisible by what? 2. So So I can change this to 1 over 38, hopefully. All right, what's nice about this is if I reduce it to 1 over something, I'm not going to even have to divide. 1 times h is just h. H is going to equal 5 times 38, right? Which was what, 190? Yes. 150 plus 40. All right, so 190 feet is how tall we are saying that particular flagpole is, because it's just created 2 ratios. All right, anytime you have 2 ratios, you can set them equal to each other and you can solve. The question is, could you put them in a different order? If I had put 76 over 2, then I would have to put h over 5. So whatever order you start in, the other 2 have to go in the same order. Some interesting things that happen with similar figures. The perimeters, so your side lengths have this ratio, and we said the perimeters are going to be the same exact ratio. But what happens with your area and your volume is really what happens with the dimensions, okay? So remember when we did area of like a rectangle, if I did area of a rectangle, then I would have some measurement here times some measurement here. And when I did area, I would multiply them. 3 inches times 4 inches, and we got 12 inches squared. So when you do an area, your units are always squared, all right? That's actually what happens with your ratio. If my side lengths are in, let's say we have a similar figure here, so we'll draw. I'm going to actually make this guy bigger so that we can do like a 1/2. So if I have another rectangle and this guy is 6 and 8, my ratio is going to be 1/2, right? 3 over 6, that's 1/2. That's what's going to happen for my side lengths and for my perimeter. Those are both going to be in a 1/2 ratio. But your area is going to be 1/2 squared. That ratio is going to be 1/4, 1 squared over 2 squared. Your volume, that adds a third dimension. That's going to be 1/2 cubed, 1 over 8. So this guy is going to be 1 squared over 2 squared, or 1/4. This guy is going to be 1 cubed over 2 cubed, which is 1/8. So that's what happens with similar figures. The sides and the perimeters are in that ratio, but when you add a dimension, say area, you square that ratio. When you add another dimension, volume, you cube it. And so they're still similar and they still have a corresponding ratio, but those actually square or they cube. And so look at the example right there. The edges are 2 to 3, so they have given me what it is, all right? The ratio then of their areas is just going to be 2 over 3 squared. 2 squared over 3 squared. So this would be the ratio of the area. If they wanted the ratio of the volume, you would say 2 cubed over 3 cubed. So I would say 27 over, oh no, not 8 over 27. I was doing my bottom. 8 over 27. And that would be my volume. And so that's what happens with your ratios for prisms when you have a third dimension. Second dimension just squares it, third dimension cubes it. But you have to know this guy first to do any of those. Page 108 talks about scale drawings. If you've ever seen a scale model of something, if it's truly a scale model, then they have measured it specifically with the real measurements, and they have converted it into scale measurements, all right? So a scale drawing is really just a ratio. If you have a model airplane and it is truly to scale, then they have taken every dimension of the actual airplane, all right, and they have converted it from, you know, whatever, if it was measured in feet, to maybe inches, okay? And they've said, all right, so 1 inch represents 20 feet. Okay, and that is a type of ratio. And so for every inch that you have of the scale model, it actually represents 20 feet for the actual airplane. And that's a type of scale. You'll also see it with maps. If you've ever looked at a map, there's typically a legend, all right? The legend on the map tells you the scale of the map, all right? It'll say 1 inch represents 100 miles, okay? And so that is a type of scale. You can figure out how far apart the cities are by measuring it in inches and then converting it based on the scale that they have given you. And so scale models follow this same similar formula, all right? So look at what they've told us here. A toy manufacturer makes scale model tractors with a 1:8 scale, meaning the miniature version is 1 compared to the 8 for the real, 1:8. If the model has dimensions of 18, 11, and 12, what are the corresponding actual dimensions of the tractor? All right. Well, they have told us what my ratio is. My ratio is 1:8. All right. 1:8. Which means I can set each one of these up. I know what the scale is, right? I know the model. I want the actual dimensions of the tractor. This top one represents the model. This represents the actual. All right? So then I just set it up. The model has 18 inches. I do not know the actual for that measurement. I'm going to set it up like that. So what's going to end up happening? It's always going to be 1 times x, and you're going to end up multiplying the actual dimension by what? 8, right? Does everybody see that? So I'm just going to end up multiplying each of these by 8, right? And so what happens when I multiply this by 8? 80 plus 64, right? Something like that. 144 inches. If they want it in feet, what would I do? Divide by 12. So about 12 feet. All right. So my first one's going to be 144 inches. My next one's going to be in the same ratio. 1:8 equals 11 to the actual. What am I going to end up doing? I'm going to end up multiplying by 8. So my next one's going to be 88 inches. And then the last one is going to be in the same ratio. And I'm going to end up doing the same thing here. 1 times x equals 96, hopefully. Yes? Does everybody see that? So when they give you a scale model, all you have to do is set it equal. And they were nice. They gave me a 1 to something model. If it had been 2 to 3 ratio, I would have had to multiply across and divide, right? I just happened to just be a 1. All right. The distance between Nashville and Knoxville is 160 miles. How far apart are the cities that has a scale of 1 inch to 10 miles? 1 inch to 10 miles. So how far apart are they on the map? Set up a ratio and anytime you have word problems, you may want to make notes for yourself that you have set it up with whatever this is in the numerator, whatever this is in the denominator, because it will help you not flip them. Sometimes people accidentally flip the second guy and then their cross multiplication is wrong. All right.